Okay, good afternoon, you guys. This week I have no live classes, so I wanted to make a few videos to help you out. So today I am going to look at lesson 6, solubility rules and precipitation reactions. I will embed this video just before this lesson. It should make things a little bit easier for you. Okay, so first of all, I want to talk a little bit about precipitates, and then I'm going to talk about solubility rules. Remember, solubility is the ability of something to dissolve or not dissolve. So if something is insoluble, it does not dissolve. If it is soluble, it will dissolve. So a quick reminder, a precipitate looks like this, kind of this cloudy-like substance. They could be any color really. This one just happens to be yellow. Several of them precipitate into yellow, but a precipitate is a solid substance, or it is an insoluble substance that is formed between two aqueous solutions in a double displacement reaction. Okay, so first of all, again, insoluble means it will not dissolve in water. So precipitates, all precipitates are insoluble. So if something precipitates out, okay, it means it is insoluble and it is going to fall out of the liquid and make a solid. So precipitates in chemical reactions are represented with the letter S in parentheses. If something is let me start over. Yes, just kidding. If something is soluble, okay, that means it can dissolve in water. That means it's aqueous. Okay, the substance makes an aqueous solution, which means the substance can dissolve in water. So if something is soluble, we would label it AQ, meaning it is an aqueous solution and it will dissolve in water. So double displacement reactions some can't, form precipitates. But if you think all the way back to, I don't know, I think it was unit 4 or 5 last quarter, I should say quarter 1, you had a handful of different types of chemical reactions. You had single replacement reactions, you had combustion reactions, you had synthesis, you have decomp. And one of the last ones Bright Thinker talked about was a double displacement reaction. So a double displacement reaction looks something like this. You have an ionic compound plus an ionic compound yields. So in a double replacement reaction or double displacement, our two cations are going to switch places. So I would form AD plus CB. So our cations swap places. So in a double displacement reaction, you have two ionic compounds that form two ionic compounds. And quite often, these reactions form precipitates. Now, precipitates, again, these are the substances that fall out or become solid when the reaction takes place. So a lot of times when we're talking about different types of chemical reactions, you will be asked which is the precipitate or which is the solid or which is the insoluble substance in the reaction. So in order to do that, we have to be able to take a look at our solubility rules. So I'm going to come over here. So solubility rules, these are rules that tell us what substances are soluble and which precipitate out or are insoluble in a double displacement reaction. Now, this chart is a little tricky, but not too bad. I'll tell you how I like to read it. Okay, so first of all, soluble, okay, means aqueous. It will dissolve in water. Okay, over here it says common exceptions. I always like to think of it as unless it is bonded to something over here. Then it will be a precipitate. Insoluble means S, or it will precipitate out. So if you have a substance that is bonded to one of these, okay, it will be a solid or it will precipitate out. Unless, again, I like to think common exceptions are more like unless this substance is bonded to something over here, then it would be aqueous. These substances in the first column, these are going to be anions. These are going to be the second ion in a compound. Same with down here. So you're usually going to be looking at the anion, and then you're going to see what it's bonded to decide, is it aqueous or is it solid? Is it solid, precipitate, or is it aqueous? So for me, I like to say, okay, substances that are bonded to bromine are aqueous unless they are bonded to silver, lead 2, or mercury 1. Or I can come down here on this side, I can say substances that are bonded to phosphates will precipitate out unless the phosphate is bonded to ammonium or alkali metal cations. So alkali metal cations are found in group 1, except for hydrogen. Okay, so let's practice this a little bit. And come back over here. Again, I am going to put my AQ, and I'm going to say unless. And then this would be solid, and this would be solid. The solid's a precipitate, and this will be unless, and this would be AQ. So this precipitation reaction right here on the very first slide that I have a picture of is the following reaction. We've got potassium iodide plus lead 2 nitrate yields, I'm going to run out of room here, kind of move some of these down, unless solid, aqueous, solid. This is making it too hard for me to read, but we'll give it a try. As aqueous. Okay, so here's my reaction. Potassium iodide plus lead 2 nitrate yields potassium nitrate plus lead 2 iodide. Okay, we probably want to balance it just to make sure we're doing everything properly. Now, in a double displacement reaction, our reactants are always aqueous, okay? So if you were to look, you can see one of my substances right here is dissolved in water, and the other one was clear, dissolved in water, and then when we put them together, it formed a precipitate. So I can right now say this guy is aqueous, and this guy, oh, let's do it properly here. This guy is aqueous. I'm going to erase this, put it where it should be, and this guy is aqueous. So right now we're saying aqueous potassium iodide combined with aqueous potassium nitrate will form potassium nitrate and lead 2 iodide. My question is this: which of these two substances actually made that yellow solid, or which one precipitated out? So what we're going to do is we're going to use our solubility chart. We always start with the anion, okay? So these substances right here are aqueous unless they're bonded to something right here. So I'm going to find nitrate. See where my nitrate is. Here's nitrate. So nitrate is aqueous unless It says none. So there's no exceptions. There's no unless. So anything bonded to nitrate is always aqueous. So I'm going to put AQ right here. And then I'm going to find the iodine in lead-2 iodide, and I'm going to come down here. I'm going to find it here. So iodine is aqueous. So substances that are combined with iodine are aqueous unless they are bonded to silver, lead-2, or mercury-1. In this case, our iodine is bonded to lead-2, so that means it is a solid. So I'm going to put S here. So this guy right here, this is what precipitated out since he's a solid. Okay, let's do another example or two. Again, let's try and kind of mark this guy up a little bit, because I might have to rewrite this equation to make things a little bit. Okay, so soluble is, don't forget, change my colors. Soluble is AQ. Common exceptions is unless. And then unless, then it would be soluble. Insoluble is solid. Common exceptions are unless. And then it would be aqueous. Okay, so let's take a look at our question that I moved to the bottom. It says, in the following chemical equation, which of the components is a precipitate? So I'm going to rewrite it. NiCl2, so that's nickel 2 chloride, and sodium sulfide yields nickel 2 sulfide plus sodium chloride. Okay. So it says in the following, which of the components is a precipitate? So in all double replacement reactions, our reactants have to be aqueous. Okay, and we can check that, but they have to be aqueous. So I'm going to put AQ, sure, squeeze it in and do it properly. AQ and AQ. If they're not aqueous, then the reaction's not going to happen. Okay, so I'm going to start with nickel 2 sulfide. I am going to find my sulfur, and I'm going to go down to my solubility chart. So substances, okay, that are bonded to sulfur will precipitate out unless they are bonded to ammonium, the alkali metal cations. So the alkali metals are like lithium, potassium, sodium, what am I missing here? Let me see if I can go find my periodic table here real quick. Desktop, find my periodic table. I'm running out of time. Here we go. Okay. My periodic: lithium, sodium, potassium, rubidium, cesium, and francium. Okay. So it says sulfides are solids unless they're bonded to ammonium, alkali metal cations, calcium, strontium, and barium. So there's none of the unless. So since it's bonded to nickel, this guy is going to be my solid or my precipitate. We'll check this other one. So now we're going to find chlorine. Chlorine, so substances bonded to chlorine will be aqueous unless they are bonded to silver, lead, that's lead-2, or mercury-1. So it's none of those, so it has to be aqueous. So which of the components is the precipitate? Nickel 2 sulfide. Let's try and do one more here. Put it down here. Again, soluble is